Hi there. This is um my fix-it assignment for my Unit 1 test. Um, so I guess I could just get right into it. The first question that I missed was this question over here. Object A is released from rest height at h at the same instant. Object B is thrown downward from the same location. Which of the following graphs of speed of v as a function of time t is correct for the two objects? So I got this question wrong because I would say it's a guess, but I guess my thought process at the end to choose this as my guess was that um, because object A is released from the rest height h, and at the same instant object B is thrown downward. For some reason, I read that as the same height, and so in my head, I thought since both objects are being thrown from the same place, they need to start at the same place, and I chose this answer, which is a little weird because this is a velocity versus time graph, not a position versus time graph. The correct answer is this answer choice right here, where the lines are parallel to each other. This is because both objects are going to be in free fall, meaning that the only force being acted on them is gravity. And the objects are going to be accelerating. And because both objects are in free fall, they are both experiencing only gravity, and their acceleration will be the same. It will be the value of gravity, which is negative 9.8. And because the objects have the same acceleration is the same as the slope of the velocity. And because acceleration is the same, that means that the slope of the velocity should also be the same. And therefore, it's the correct answer choice is right here because in the velocity graph, the slopes are the same. I actually decided to use the ball toss answer key to relate this to something we did in class because in the ball toss lab, when we threw the ball in the air, it was also in free fall. And because it was in free fall, the only force on it was gravity, and it was the acceleration was the value of gravity, which was 9.8. And that's the value we should have gotten on the ball toss lab. Regardless of the object, the acceleration of an object thrown in the air and in free fall should be pretty much around 9.8 because gravity is the only thing acting on it. And that relates to the question because knowing that, I would be able to realize that both objects were in free fall and therefore they have the same acceleration. Because of the same acceleration, they would have the same slopes of velocity. Okay, the next question that I missed was this question over here. So a graph is given, and pretty much you're just supposed to rank the displacements from greatest to least. And the reason I chose this answer was simply because, again, similar mistake. I didn't really recognize it was a velocity versus time graph. I was rushing a little bit, and my thought process was that over here in the first segment, it moves 4, and that's the displacement. And over here, it moves in a negative direction, 3, and for the third segment, it moves 4 in the positive direction. So because both 1 and 3 had a displacement of 4, which is not true, they're equal to each other. And then since this is negative and going in the negative direction, it was less than 0. And this was wrong. The correct answer was that 3 is greater than 2, and 2 is greater than 1, and 1 is greater than 0. And this is the reason behind it. To calculate displacement, we would have to take the areas of each of these segments. So looking at this triangle, has a width of 2, length of 4. 4 times 2 is 8. This is a triangle, you have to divide by 2. So 8 divided by 2 is 4. So segment 1 has a displacement of 4 units. We look at 2, it has a width of, there's a triangle, but there's also a rectangle. So we have to account for that. So the rectangle has a length of 2 and a width of 1. So 2 times 1 is 2. So we hold on to the 2, and then we look at the triangle that is also a part of 2, and it has a width of 2 and length of 3. So that's 6. 6 divided by 2 is 3. And then 3 plus the 2 that we got from the rectangle is 5. So segment 1 has a displacement of 4. Segment 2 has a displacement of 5. Now, for segment 3, there's also a rectangle and a triangle. So the rectangle, same thing. Width of 2, length of 1. So 2 times 1 is 2. We hold on to that. Then the triangle has a width of 2 and a length of 4. So 2 times 4 is 8. 8 divided by 2, since it's a triangle, is 4. So 4 plus the 2 from the rectangle is 6. So segment 1 has a displacement of 4, segment 2 has a displacement of 5, and segment 3 has a displacement of 6. So that would be the correct answer here. And this was also taught in this lesson, where we learned that you would have to take the area given a velocity versus time graph of the segment to be able to determine the change in position or displacement in position. So that should have been done for this question, which I didn't do, and that's why I got it wrong. I'm going to go ahead and do the question on the very bottom using kinematic equations. So the reason I actually missed this question was because I didn't see it. It was question 11 for me, and on, I guess, the tab of questions, I saw 1 through 10, and for some reason, when I scrolled, it just didn't seem to appear. I didn't see it. So I didn't know this question was there, which costed me a lot. It was pretty stupid, but I'm going to go ahead and work it out. So the question, we have several given values, and it looks like we're going to have to do a segmented motion diagram, which you taught us how to do right here in this lesson. And so, yeah, if I saw the question, I think I would be able to apply what I learned from here. We did several examples on the board as well. So let's go ahead and solve this question. So we're going to start by drawing our segmented motion graph. And just don't mind my neatness on this. So we have this. We can go ahead and start off by saying that the position at 1 is 0. Time is also 0. And we don't know the initial velocity. We do not. Okay, then, sorry, this is taking slow. I have to do this on a computer, so it's giving me a bit of trouble. Oh. Okay. Then we have the position at 2, which is what we're looking for in the problem. We have time at 2. And we know that this is 7.55 as it's given. And I'm going to finish, I guess, drawing all the givens and stuff right now. That should not be a 0. That is a question mark. That's what we're trying to solve. And then velocity at 2, or I guess, yeah, second velocity. That's what we have to solve. We have to solve for that as well. We do not know that. Position at 3. That is also unknown. We know the time is 10 because they told us that after 10 seconds. I'm going to go back just to clear up how I got these values. They're all given in the problem. Okay, so V3 is 0. Because we know that the car stops. And then the ones in between, we can do delta x of 1 to 2. Or you don't have to write that. We don't know. That's kind of what we're looking for here. Since this is 0, it will be the same as this value, which is what we're trying to solve for. We know that time is 7.55. And we don't know the acceleration either. Then over here, you know that the displacement over here. Actually, hold on. Let's go here. Sorry. Okay, got it. You know that this is 3.8 because it's given. Time. Okay, so it's not given, but it's out of the entire frame is 10 seconds, and we know that the first chunk takes up 7.55. So you know the next chunk would take 2.45 seconds. You just do 10 minus 7.55. Okay, and acceleration. Don't know that. Okay, this is all of our givens. So, and this is all, I mean, you know the problem. I'm just, I guess, showing you I know how to do this. So now that I have my givens, I'm going to go ahead and start by trying to find this middle velocity because we have everything we can to do so. And to be able to do that, I'm going to go ahead and use the kinematic equation 2a. So this is for V2. And for V2, sorry, the second 2a is displacement of x is equal to 1/2 initial velocity plus average velocity times time. So we know that, we can arrange this in a different way. And so I guess what we're doing in this specific scenario is we're doing 1/2 V2 plus V3. This is kind of acting as like our initial velocity because we're looking at, I guess, this section. And then we do the change in time over here. So time from 2 to 3, which is 2.45. 2.45. Sorry, I would do this on whiteboard, but I don't have one. And when we plug in all the values, I mean, this can basically be simplified once plugging in the values to 2.38 all over 2.45, which is equal to 3.1. Right, so since it's 3 point, we can write 3.1 here. Okay, I'm just gonna clear some room for some more work. Okay, now what we can do is, I guess we're gonna need acceleration to find x2. So we can go ahead and do that. We can do that using just the fact that acceleration is the slope of velocity, so change of velocity over time. And we know that the change of velocity over time, this goes, the change of velocity over time is from 3.1 to 0. And so the final minus initial. Ooh. This is, I'm basically just doing the change in velocity first. So because as you can see, go from 3.1 to 0. And then this is all over the time. The time was 2.45. And this is equal to, sorry, I'm just going to write the equation so it makes a little more sense here. And this is equal to negative 1.2, or 1.27. So that way we can add this here. Okay, and now what we're going to do is we are going, we can go ahead and solve for the initial velocity now. I'm going to be using equation 3, so let me erase my work here. So equation 3, we can rearrange it so that it's V1 is equal to V2 minus A delta T. And this is the delta T from 1 to 2. And that's 7.55. So, from that, we know that V2 is 3.1. 3.1 minus the acceleration, so negative 1.27 times 7.55, because that's the time. And that's equal to negative 12.69. 12.69. So that's that. So negative 12.69. Now we can finally solve for what we're looking for using equation 2a as well. So down here, we're going to do delta x from 2 to 3 is equal to 1/2 v2 plus v3 times delta t, and you can rearrange this and I guess plug in your values so that it becomes 2 times 3.8 all over 2.5. Ooh, sorry, this is very ugly looking. But this is gonna be I'm sorry, I was looking at that thing. I had everything written down and I accidentally copied the part of V2. But sorry, you take this equation, you just plug in your values. So it'd be 1 half 12.69 plus 3.1 times 7.55. This, once plugged in, would be 59.6. I would have done this, I guess, completely live on a whiteboard. I don't have one, so I had to write it on paper, and it's been a mess. So I apologize for that, but I do know what I'm doing. And now we have to go over the FRQ. I did okay on the FRQ. So looking at what I missed, the only points that I missed. I'm sorry, I forgot. With the problem I just did, I guess it was just something we had to solve out. But every single WebAssign question had to do with using kinematic equations, and it would have applied and segmented motion, which I showed. Over here, this can be applied. This is actually very similar to a warm-up that we had, which is this over here. And so going back to the FRQ, now I can go ahead and just talk about my mistakes. So over here, the first points that I missed was part B, the first part. And I got 3 points, but there was 3 other points I could have gotten. I had to say something that had to do with that was displayed on the graph, and I didn't. I could have said that it appears that the average rate of change is the same for both at TD, and that's my student was correct as shown on the graph. I didn't do that, so I missed those points. Then over here, same thing happened. I got +3, but I actually graded myself wrong in the rubric for the test. If I go to the FRQ, yeah, if I go to the FRQ, for identifying a feature of the graph, the area both under the sorry, no, this is the wrong one. For identifying a feature on the graph, the final speed of the car is twice the speed of the truck. I did that, and for some reason, I did not award myself those points. I said the velocity in the graph, the velocity of the car is about double the velocity of the truck at time D. So that cost me some points, which was really, really, really stupid. So part A and part B are now covered. Part C, I got 2 out of 3 points awarded. I got 1 for using these some, I guess, kinematics, not equation, but some equation having to do with kinematics. And then I also identified that the velocity of the car was 2 times the velocity of the truck. But I didn't get my answer completely right. I forgot the squared, so it would be 2v square t all over 2d, not td. And I got this wrong. My thought process was just that I'm looking for the acceleration. I know that acceleration is change in velocity over time, and I know that change in velocity is velocity final minus velocity initial. So I know that the velocity final of the car was the same as 2 times the velocity of the truck, since it was double its speed. So I replaced v final with 2vt. I replaced v initial with 0 because the initial velocity was 0. So it'd be 2vt minus 0 over here, which would be the change velocity. But of course, you have to actually use a kinematics equation. So over here in part C, I was supposed to use this. I guess from the fifth, yeah, the fifth kinematic equation. And by doing so, we know that the velocity of the car is just 2vt, and then you plug that in, the initial velocity is 0, all over 2 times the change in x, which was d. So it'd be, well, I mean, it kind of speaks for itself. It was a really stupid mistake. Instead of using a kinematic equation, I just kind of tried to use logic. It didn't really work out in my favor. And that's why I didn't get the point over here. So 1 point was taken out from there. And then my part D was good. So yeah, I think that is my test.